In this video, I want to solve an exponential equation where we have an exponential multiplied by some constant equal to a number. Now, because of the orders of operation, where we have to do exponents before we can perform multiplication, this left side cannot be simplified. The left side is definitely not equal to 14 to the 3x plus 2. So instead, we start this problem by isolating the exponential, dividing both sides by 2. And we get 7 to the 3x plus 2 is equal to 8. And at this point, we are in the same situation that we were in the last problem. A single exponential equal to a number. One way to solve for the unknown in this exponent is to write this expression in logarithmic form. In this case, we have 3x plus 2 is the power that we raise 7 in order to get 8. Log base 7 of 8 is just a number, so this is now a linear expression in x. To solve for x, we simply subtract 2 and divide by 3. This is a number. It is the exact representation of the solution for this exponential equation. Let's look at one more method. Instead of writing it in logarithmic form, we could also take a logarithm of both sides, as we saw in the last video. A nice choice here would be to take log base 7 of both sides, since log base 7 of 7 to a power is just the power, and so that would be a nice clean way of getting x out of the exponent. But since that ultimately leads us to the same place as our first method, let's try instead using a different base. Let's try taking log base 10 of both sides. Using a property of logarithms, when we're taking a logarithm of something to a power, the power comes out in front. And we multiply that by the logarithm. So here we get 3x plus 2 times log base 10 of 7 is equal to log base 10 of 8. And now I need to isolate the x term on one side of the equation. So one thing I might do here is distribute log of 7 over 3x plus 2. Okay, so now I have one x term, 3x times the log of 7. I want to isolate that x term. And then divide both sides by 3 times log of 7. And here we have our solution. This is just a number. It is the exact representation of the number that satisfies this equation. And even though this is very ugly, it is indeed the same solution as our first method, which through some manipulation and use of change of base, you can verify for yourself. One thing that comes across when we use this method is it's a much uglier process than simply writing this in logarithmic form.